Pressure is inversely proportional to volume. I will remove the proportionality constant and P is equal to K into 1 by V. This is called as Boyle's Law's equation. Here we should come to know that always we have to note down at what temperature it gets converted from one form to another form. On that concept, thermal energy arises. It's a repulsion between electrons of two atoms which is present in valence shell. Then only we will get a molecule. Hello everyone, I am Venu Prasad, Department of Chemistry, Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. Today I am going to take Unit 5, States of Matter, Session 1. Okay, let us study today what do you mean by states of matter and intermolecular forces and its types, thermal energy, gaseous state and its laws, relationship between density and pressure of a gas by using Boyle's law. Okay. Next thing, first thing, let us study what do you mean by states of matter. First, if we are going to study about states of matter means, first thing we have to learn is, in our nature, there are different types of substances which I can see. Correct, right? There are different types, solid-like substances, liquid-like substances, as well as gaseous state. There are three states in the nature. Correct. First thing is solid state, liquid state, and third one is gaseous state. What do you mean by solid state? When the substance is in the solid form or it is in the crystalline form, then we can say it is in a solid state. Same substance, if you apply a little amount of heat for that, what will happen? It will be converted into liquid state. Okay. Next thing is, third thing is gaseous state. If you apply little amount of energy to the liquid state, when the atom or when a substance is in the liquid state, if you supply little amount of energy, what will happen? Just it will convert into vapor form. We can see some amount of vapors in that. So there are three types of states of matters are present. First thing is solid state, second one is liquid state, third one is gaseous state. Okay, there are three important states of matter, as I said, solid, liquid and gaseous, and it depends upon what factor it depends. It depends upon intermolecular forces and thermal energy. Okay, so the balance between these two determines the states of matter. We have to balance these two factors. When we balance these two factors, then only we can say this substance is in this state. When the substance is in the liquid state, it should have some temperature and it should maintain some pressure. Then only we can say the substance will be in the liquid state. If the substance is in the solid state, we have to maintain some temperature, pressure, density and all we have to maintain. Then only we can maintain such type of substance in a particular format. Otherwise, what will happen for our ice today? Let us take on ice, which is in the solid state, correct, right? So if you bring that solid ice to the room temperature, if you keep it in a room temperature without maintaining any temperature, it should be there for long time, means what we have to do? Ice should be preserved below 4 degrees Celsius or below 0 degrees Celsius. We have to preserve it. Otherwise, what will happen? It will be converted into liquid state. So we have to maintain their pressure, we have to maintain their temperature. Then only we can preserve the ice. Otherwise, what will happen? It will be converted into liquid state. Correct, right? So same, if we take alcohol, today let us take alcohol. If you preserve it in the fridge, which is kept in open bottle, then also it will be preserved. It will not evaporate. Same alcohol, if you keep it in a room temperature, what will happen? It will be abstracted to the atmospheric temperature. Correct, right? So we should maintain always temperature and pressure for a particular substances. Then only we can maintain. Otherwise, it will be converted from one form to another form. We can say, generally we can say it is getting oxidizing. It gets oxidizing. We can say generally. Okay. So now let us see what do you mean by intermolecular forces. Okay. Here intermolecular forces and its types are there. Okay. Here these are the force of attraction and repulsion between the interacting particles, or that is called as atoms or molecules. Means it's a force of interaction or it's a force of attraction between two atoms. Then what will happen? When two atoms combine, we will get a molecule. So in what way they are combining? Repulsion between two atoms only takes place only in the presence of valence electron. Both atoms should have a valence electrons. Their repulsion takes place. When these two electrons get repelled, what will happen? There is a formation of a molecule. So in generally we can say that it's a repulsion between electrons of two atoms which is present in valence shell. Then only we'll get a molecule. There is an interaction between two atoms, right? So they are called as interacting forces. Okay, here also they have said interacting forces. So I have said atoms or molecules. The attractive intermolecular forces between particles is called Van der Waals force. Means the force of attraction between two valence electron which is present in atoms, then it is called as Van der Waals force. Okay, next thing is dispersion force. What do you mean by dispersion force? It's a force of attraction between two temporary dipoles. Then it is called as dispersion force. Okay, it's a force of attraction between temporary dipoles between which type of atoms? Between neutral atoms and a molecule. There should be neutral atoms. Then there will be a dispersion forces, correct, right? Or temporary dipole forces. Then we can say that it is a dispersion force. Next, the atoms and non-polar molecules. Now let us take atoms and non-polar molecules are electrically symmetrical. But when they have close vicinity to each other, what will happen? Momentarily, electron charge distribution takes place. Then what will happen? It becomes unsymmetrical. If electron gets excited from one form to another form, what will happen? Their unsymmetrical distribution of charge takes place. So they have said it is unsymmetrical. Okay, and it is called, develops a dipole. Just what you have to think is the atoms and non-polar molecules, they are electrically symmetrical. But when they have close vicinity to each other, when you keep them in a closed environment, when you keep them very close, what will happen? The momentarily electron displacement takes place, distribution of charge takes place. When distribution of charge takes place, what will happen? It becomes unsymmetrical. And develops a dipole. See here, atom 1 and atom 2, they are kept open, or it is kept at open environment and it is kept in close each other. Open environment, but they have kept very close. Then what will happen? This is atom 1 of different charges and atom 2 of different charges. Did you understand? This is called dispersion forces. Next thing is intermolecular forces and in types, and second point is there, that is known as dipole forces. What do you mean by dipole forces? These are the forces act between the molecules possessing permanent dipole moment. Then it is called as dipole forces. It's a force of attraction between molecules. We should know that it is a force of attraction between the molecule which has got permanent dipole moment. Then it is called as dipole forces. Here you see molecule they have said, okay, they should have two types. Molecules means two atoms should combine, right? So then only we can say that it is a molecule. Here I have taken two molecules, HCl. Both have got opposite charges, H plus ion and Cl minus ion. Here force of attraction takes place here between opposite charges and here like this. That is called dipole forces. Next thing is dipole-induced dipole. Dipole-induced dipole. This is the third type. Okay, this is an attractive force which operates between polar molecules. Polar molecule should be there having permanent dipole moment, and the molecules lacking permanent dipole. One should have permanent dipole and another molecule it is lacking. One charge has been lost. Then such type of molecules interaction takes place. One molecule will have permanent dipole moment, another molecule will have permanent dipole moment but it has lost one electron. If it lost one electron, what will happen? It will not have permanent dipole moment, right? So it's a force of attraction between two atoms which has got such type of features. First thing is one molecule should have permanent dipole moment, another molecule should have molecule having lacking permanent dipole moment. molecule lacking that we should think. Okay, permanent dipole moment. Permanent dipole moment of polar molecule induces dipole. Permanent dipole of polar molecules induces dipole on the electrically neutral molecule. Electrically neutral molecule. So it will transfer its energy to the neutral molecule by deforming electronic cloud. Deforming electronic cloud. So thus an induced dipole is developed in the other molecule. One molecule have permanent dipole moment and another molecule, one neutral molecule will be there. From this, electrons has been transferred to the neutral molecule. Then what will happen? Dipole, induced dipole moment takes place. Such type of forces are known as dipole induced dipole. Okay. Here these are some molecules. Here is a polar molecule. Polar molecule means what? They will have opposite charges. This also two polar molecules I have taken. Non-polar molecules, see, here there is no any charges. Only one type of charge will be there. And induced dipole, here you see. This is a neutral molecule we can take. Force of attraction between polar molecule and non-polar molecule. You will get indeed polarity in the non-polar molecule. Okay. Next thing is, fourth one is hydrogen bond. What do you mean by hydrogen bond? It's a bond between one electronegative atom and a hydrogen. Correct, right? So that it is called as hydrogen bond. But it's the energy of the body. It's the energy of the body arises due to the motion of its atoms. Motion of its atoms and the molecules. First thing we can say like this. But in generally means we can say in organic chemistry, if you are coming to the concept of organic chemistry, hydrogen bond means always we should think that hydrogen has got one electron. It requires some amount of energy to fulfill its orbital. So what will happen? It should react with electronegative atom only. Halogens, they have got electronegative, correct, right? Why we can say like this? Because halogen has got one more electron. It requires one more electron to complete its fully orbitals. For example, chlorine, its atomic number is how much? 17. It requires one more electron to fulfill its inert gas configuration. So hydrogen can interact with chlorine. So there is a formation of HCl molecule, correct, right? So the force of attraction between a hydrogen as well as an electronegative atom. So we can say that it is a bond between electronegative atom and a hydrogen. Then it is called as hydrogen bond. But it arises due to the motion of its atom and the molecules. Then thermal energy is directly proportional to the temperature of the substances. Always thermal energy depends upon the temperature of the substance. Why it depends? Because at particular temperature only that molecule gets converted from one form to another, and we will come to know that how much energy we have to supply. Then only we will say that, oh, for this molecule, it requires this much amount of energy. Then we will supply little amount of energy, right? We can't supply, we can't assume. We should know at what temperature it gets converted from one form to another. Then only we will come to know that, oh, this has got some amount of energy. We have to supply this much temperature. Correct, right? So thermal energy is always directly proportional to temperature of the systems or temperature of the substance. Okay. Next, now let us come to the concept of thermal energy. It is the energy of the body arises due to the motion of its atom and molecules. The thermal energy is directly proportional to temperature of the substance. Directly proportional to temperature of the substance. Okay. Here we should come to know that always we have to note down at what temperature it gets converted from one form to another form. On that concept, thermal energy arises. Okay. Next thing is gaseous state and its laws. First thing is it is characterized by from physical properties. First thing is gases are highly compressible. Second thing is gases exerts pressure equally in all the directions. Gases have much lower density. They have got lower density than solids and liquids. They have got lesser density than which one? Solids and liquids. We should know that. And volume and shape of the gases are not fixed. They don't have any particular shape. All depends upon the size of or shape of the container. They are assume the volume and shape of the container. They always take the shape of containers, not they don't have particular shape. Okay. Next thing is the gases mix evenly and completely in all the proportion without any mechanical aid, they have said. Means gases will react with everything. For example, if you kept today one small amount of any chemical, for example, sodium hydroxide or any other potassium hydroxide, any other chemical, let us take. If you keep it in an open atmosphere or if you keep it in a closed lid, okay, I'll open and keep bromine or I'll open and keep iodine bottle. What will happen? Fumes from the iodine goes and deposits in which one? Sodium hydroxide bottle. We can see the observation. We can see the change in observation of that bottle. We can see color change. Correct, right? So what we have to think, always gases interact with atmosphere. It will interact with the atmosphere very easily. In atmosphere, gases interact very easily. Correct, right? So it does not require any mechanical aid. It does not require any mechanical force. Just it will interact with the substance which will absorb that such type of gases. Okay. Next thing is Boyle's law. Now let us see. First thing is Boyle's law. What do you mean by Boyle's law? It is the relationship between pressure and volume. And it states that at constant temperature, the pressure at a fixed amount of gas, varies inversely with its volume. This is known as Boyle's law, and this law is the law gives the relationship between pressure and volume. First thing we have to say that at constant temperature, pressure of a fixed amount of gas, varies inversely with its volume. Then it is called as Boyle's law. Okay, here you see. From this graph, we will come to know about the pressure as well as volume. Here you see, as pressure decreases, volume also decreases. Here you see 600 K, 400 K, 200 K. But here you see temperature and volume I have taken. Okay. As volume increases, what has happened? Temperature, you see, temperature goes on increasing. Okay. We should know this. At constant temperature, pressure of a fixed amount of gas is inversely proportional to its volume. So we can say that this is the relationship in this Boyle's law. But we should think that as volume decreases, pressure increases. Volume increases, pressure decreases. This relationship we should know. Okay. Next thing is Charles' law. This law shows the relationship between temperature and volume. Here at constant pressure, temperature and volume means we have to keep the pressure constant. At constant pressure, volume of a fixed mass of the gas, is directly proportional to absolute temperature. At constant pressure, volume of a fixed mass of a gas, is directly proportional to absolute temperature. We should know this. Here you see pressure and temperature. What will happen? As temperature increases, what has happened? Pressure decreases or increases? P1, P2, P3, P4 has given. P1, P2, P3, P4. Pressure increases as temperature increases. We have to keep at constant pressure. Here you see at constant pressure, volume of a fixed mass of gas is directly proportional to absolute temperature, they have said. So P1 is less than P2, less than P3, less than P4. P4 has got how much temperature? Highest temperature when compared to P3 and P2 and P1. This is the relationship we have to know. Okay. Next thing is Gayloss law. Here this relationship shows the only pressure and temperature. Pressure and temperature we should know. Okay. At constant volume, what will happen? Pressure of a fixed mass of gas, is directly proportional to temperature. We should know this. Pressure is directly proportional to temperature. Directly we can say. But what we have to keep constant? We have to keep constant volume here. If you keep the constant volume, pressure is directly proportional to temperature we have to maintain. Okay. This is known as Gayloss law. Here also you see, as temperature increases, what will happen? Volume decreases, right? See here, temperature increase. If you increase the temperature, volume decreases, because if your temperature increases means if your substance is in the liquid state, if you supply highest temperature, what will happen? Its volume goes on decreasing because it gets converted from one form to another form. So we have to keep their constant volume is kept. When constant volume is kept, we should think that pressure and temperature is same. There is no varying. If temperature and pressure is varying, what will happen? You cannot keep the constant volume. It will be goes on changing. Okay. Next thing is Avogadro Law. Here Avogadro Law means just volume and amount relationship we should know. Okay. Here under similar condition, we should know that under similar condition, equal volume of gases, equal volume of all gases contain equal number of molecules. Equal number of molecules. Equal under similar condition, equal volume of all the gases. Equal volume of all the gases contain equal number of molecules. Example, V is directly proportional to N, we can say, or we can say if you remove the proportionality constant, we have to keep one constant, right? So I have kept K4 as a constant here. First thing we have to think, volume of all a gas is contain equal number of molecules, correct, right? Then only we can say this much volume has got, means for one molecule, then we should think that they will have some amount of atoms or some amount of electrons in it. They should have equal number. Then only we can stay for a particular time and we can maintain some volume. Otherwise, what will happen? It may change. If it does not contain correct amount of molecules, what will happen? It may change. It will react with atmospheric temperature to interact with its temperature, correct, right? So we should say that if the gaseous state, when the atom is in the gaseous state, then it will have equal number of molecules. If it does not have equal number of molecules, what will happen? We should think that it is interacting with atmospheric temperature. Then only it has got changing. But if it has got same, all the molecules in the gaseous state, if it has got same number of molecules which is in the liquid state, then we can say it has got stable density, or it has got stable configuration. Okay. Next thing is relationship between density and pressure of the gas by using Boyle's law. We know that from Boyle's law, P is inversely proportional to volume. Okay. Next, if you are removing one proportionality, we should take P is equal to K into 1 by V. This is the equation for which one? Boyle's law. This is an equation for Boyle's law. Here we have to think that relationship between density and pressure. So we know the formula for density. What is the formula? D is equal to mass by volume. Correct, right? Or we can represent density as rho. Rho is equal to mass by volume. Okay. Now we have to think that mass I have got. Correct, right? Mass and volume I have got. I can give the relationship to this. Okay. Next, what you have to do? We know that we can write like this. Density is equal to mass into 1 by volume. Okay. So I will take D divided by M is equal to 1 by V. Here also I have got 1 by V. There also I have got. So I'll substitute the value of this. Okay. P is equal to K into D by M. I have substituted. Okay. Next, what I have to do? I'll take this M here. Okay. So P into M by D is equal to K. Next, I'll substitute here P into M is equal to K into D. Okay. So next, what I have to do? I have to take D. D is equal to P into M by K. Okay. This can be kept constant. If I kept constant, what I will get? D is directly proportional to pressure. Okay. This is the relationship between density, pressure by using Boyle's law. Okay. So we can say that at constant temperature, density is directly proportional to pressure. Okay. So first thing, pressure is inversely proportional to volume. I'll remove the proportionality constant and P is equal to K into 1 by V. This is called as Boyle's Law's equation. We know that density is equal to mass by volume. Next, what you have to do, D is equal to mass into 1 by V. I'll keep 1 by V on the right hand side. Then I'll take M this side. So D by M is equal to 1 by V I got. So I'll substitute the 1 by V value in Boyle's law. So P is equal to K into D divided by M I got. Next, what I have to do, I'll take this M on the left hand side. P into M by D is equal to K. Next, what I will do, just I'll take D on the right hand side. If I take D on the right hand side, P into M is equal to K into D I got. Then what I have to do, I should take the value of D, because they have asked the relationship between density and pressure, correct, right? So I have to relate this one. So I have taken density on the left hand side and pressure on the right hand side into M by K. If I consider M by K as a constant, then I can put D is directly proportional to P. This is the relationship between density and pressure of the gas by using Boyle's law. Here K dash I can take, okay, K dash is equal to M by K. This is the constant we have to represent, right? So I have written like this. So this is the relationship between density and pressure of the gas by using Boyle's law. Okay. In next session, I'll be studying about ideal gas equation. Okay. Thank you.